Hello everyone. So welcome to the class of text analysis. So till now we have covered what is text analysis. We introduced text analysis, and then we learnt about how you can clean the text, right? So we worked with the pre-processing of text. Then we talked about cleaning of text, bag of words, TF-IDF, tokenization, stop word removal, lemmatization, and named entity recognition, and etc. There were many more things that we covered, right? In the last week, we also covered sentiment analysis, where we discussed why sentiment analysis is very important for business companies and organizations, because sentiment analysis helps them to understand the various sentiments associated with a text or a document, and thus with the product, you can say. So accordingly, by understanding the sentiment, whether it is a positive or a negative sentiments or 8 emotions that we learnt about it, so the companies can make changes or adjustments to that product or service or anything, right, for that. So sentiment analysis is very important, and here we learned about NRC lexicon, or rule based technique, and then we also learned about a deep learning method, which is BART, right. So all this we have covered, and today, in the fourth week, we will cover topic modeling, right. So we will introduce what is topic modeling and understand topic modeling as a distribution of words, and what is its application, and what are the most popular topic modeling algorithms. So, and what is LDA, and then advanced tools also we will cover, like NFM and BRT, right. So this is all we are going to cover in the topic modeling, right. So let us start with this important topic, because this is extremely useful, because it helps researchers, organizations to understand how to classify, how to cluster, how to distribute the topics, right, in a manner that becomes more easy to understand and take corrective or right actions, okay, or build correct strategies, right. So what is this topic modeling and what is its need, right. So if you can see, there is a huge growth in the text, right. So nowadays you are bombarded with text around you, right. So the world is generating text at a huge pace, right, unprecedented rate. Every second, there are news articles, blog posts, research papers, books, magazines, journals, and social media updates, which are coming up every moment, every second, right. And these documents, these materials are carrying lot of important information. It is like a data mine, okay, it's a data mine. So businesses, researchers, and government, they want to seek or extract valuable information or insights from these vast oceans of textual data, right. But manually you can't do it. Manually it is just impossible. So categorizing and analyzing them through a better method, through a more recent approach, or you can say more on a computational manner, is practically the thing that we are going to do, right. So that's what we have done in the last few weeks also, right. So but today we'll be talking about how topic modeling is becoming so helpful, why it is becoming so helpful. So topic modeling comes in as a powerful tool in natural language processing that helps to uncover hidden structures in the large text collection. So you have text collections from various sources, right, as we discussed. And the question is, how would you classify them? And how would what are the structures, inherent structures inside it? So how would you differentiate, or how would you separate them, right? So as it says, topic modeling is an unsupervised, right, machine learning technique that identifies group of words that frequently appear together in documents. So it helps us to understand the main theme of a data set. Now, for example, you can look at a book, and suppose the book does not have a title. Let's say, imagine. So if you are asked to give a title to the book, what would the title be? Obviously, the main theme of the book, isn't it? Suppose you are writing a research paper. What is the main theme? So that becomes the title of the research paper. So same thing, to understand what is the main topic or main idea, theme behind the entire document or the entire basket of text, is something that is very important, right. So unlike predefined classification or keyword searches, topic modeling automatically determines the topics present in a corpus without requiring labeled data. So it does not require any labeled data. So it is a process of unsupervised machine learning, as we said, right. So the machine would try to learn on its own, okay. Suppose you analyze thousands of customer reviews. Now, this is an example. So, you want to analyze customer reviews on an e-commerce website. So, that is one of the most important data sources for us, right? So, instead of reading each review, topic modeling can identify themes like delivery issues, product quality issues, customer service issues, and then it clusters the words that appear together in a similar context. So, through this, a company can understand what are customers talking more about its about its products, its services, its price, or what exactly they are talking. So, by that, and is it that are they talking positively or negatively? Through this, they can understand about the entire sentiments around the topic, right? This allows companies to quickly understand what customers are discussing and address those common concerns efficiently. So, once you can identify what they are discussing, and then you can address the concerns very efficiently. So, that is a great help to the companies to keep their customers happy and satisfied. Okay. Now, these are some examples if you can see. So, these are some examples I have just taken from some review sites, right. So, there are 9 such points which says, for example, the Galaxy 24 is an absolute powerhouse, the camera takes stunning photos even in low light, and the battery lasts for a full day, right. The S Pen is a great addition, making multitasking easier, definitely worth the investment. So, one review is this. Second review says, for another phone maybe, Apple has done it again. The A17 Pro chip makes everything super fast and the titanium design feels premium. However, I expected better battery life, right? But still, it's an amazing phone. Third one says, I love the AI powered camera and smooth Android experience. The software updates are frequent. The only downside is the battery life, which could be improved. Now, if you see all these different reviews, now because it is only 9 reviews, maybe I can, what I have done is I have highlighted, bolded some, words, keywords, for example, camera, battery, chip, right? Then software, right? And then super fast charging, apps, okay. So, these are some keywords that and software, right. So, some keywords that we have highlighted from these 9 reviews. But just imagine if instead of 9 there are 900 reviews, 9,000 reviews, or let us say 90,000 reviews. Would you just leave them just because it is too much? No, there are ways you can use it. So, if we can understand how to use this huge text for our benefit, then obviously we can make it, convert it to our benefit, right. We can make substantial benefit out of it. So, how topic modeling works? At its core, topic modeling assumes that documents contain a mixture of different topics, right, and each topic is then represented by a set of words. So, there is a document which has different topics, obviously, as we saw in the last suppose reviews. Here, if we consider it as a document, then this document has different topics, right, and each topic is represented by a set of words, right. So, maybe battery is surrounded by a different set of words, maybe charging speed is surrounded by a set of words, quality of camera or camera is surrounded by a set of words, like for example pixel, like quality of camera, or low light, low light, or flash, and all these things, right. So, instead of assigning a single label to a document, topic modeling allows a document to belong to multiple topics in different proportions, right. So, here a single label is not required, right. Topic modeling is allowing a document to belong to multiple topics, right, instead of one, which was earlier a kind of a compulsion, or you can say a challenge to us. Okay. For example, consider an article about artificial intelligence, okay, in healthcare. Now, it might be composed of 70% AI related terms like deep learning, neural networks, automation, right, and 30%, let us say, healthcare related terms like diagnosis, medical records, patient treatment. So, this flexibility now makes topic modeling a superior approach compared to the traditional classification method, which often forced a document into a single category. So, when I said you give a title to a, let us say, your research paper, so you can give only one title, generally you give one title, right, but that is forcing, that is maybe the most potential idea or theme of the entire document. But suppose that could only be 50% of the theme, right. Your other themes could be major themes could also be there, like which constitute of 30% or 20% value, but then you are just leaving it, you are taking the most important one in that, right. So, in any topic for that, right. So, that was a little challenge because we only took the number one thing and we rejected or we rejected or gave away with the second, third, fourth important topics, right. So, this problem now is removed with topic modeling. So, topic modeling, it says the fundamental idea is that topics are distribution of words. What is a topic? A topic is nothing but a distribution of words, right, and documents are mixture of topics. So, you have several topics. For example, let us say when you talk about smartphones, you are talking about camera, you are talking about processor, you are talking about the software, and again there are a distribution of words. For example, pixel, quality, light, flash, let us say updates, all these are the different words, right. But what does this mean in practice now? So, for example, imagine an article about space exploration, right. You might expect to see words like NASA or ISRO, rocket, Mars, astronaut, telescope, whatever, right. Similarly, in an article about climate change, common words might include carbon emission, global warming, fossil fuel, renewable energy, right. So, instead of categorizing documents into a single fixed label like science or politics, right, topic modeling allows the document to belong to multiple topics. So, example, the last example again, you see a report on AI in healthcare says that 70% AI related words, which we just saw in the last slide, right. So, machine learning, deep learning, neural network, and 30% healthcare. So, it is a very clear category division that 70% is AI and 30% is healthcare. So, it is not saying only it is a AI related topic. So, if you would have said only AI related, then you would have missed out the 30% healthcare related words, right. So, that is why this is a big better way of explaining things in a topic modeling or classifying things than a single labeled one. Okay. So, what is a topic? A topic is not a predefined category like sports or technology. So, generally we use those categories, no, sports, politics, technology, science. Indeed, it is a collection of words that frequently appear together in the data set. So, example, a topic related to sports might have a high probability of words like team, player, match, goal, tournament, whereas a topic on economics might have inflation, GDP, market, stocks, interest rate. So, it talks about a number of different words, right, not as a collection of words, not a single word to define, for example, economics, only sports, no, we are talking about a number of important words. Okay. Topic as probability distribution over words. Now, instead of saying topic A is about sports, topic modeling expresses this idea mathematically. How? Now, as a probability distribution over words. Now, for example, in a sports related topic, you see the word player, match, goal, tournament, and coach. Okay. Now, what is the probability of their occurrence? Now, player 0.2, right? Match 0.15, goal 0.12, tournament 0.1, and coach the last is 0.08. So, player has the highest probability in this topic, meaning it is more likely to appear in the documents discussing sports. Some real world examples. Now, let us understand it with some real world examples, some business examples. Now, in business and marketing analytics, so businesses generate massive amounts of unstructured data from customer review, surveys, support tickets, social media interaction, right. So, it helps companies to understand their customer needs, detect the trends in the market, and then accordingly they how to improve their products and services. So, first one, if you see customer feedback analysis. Now, companies receive thousands of customer reviews, right, and manually reading is almost impossible, impractical. So, topic modeling automatically identifies the recurring themes in the customer feedback. So, you see this example. A company analyzing reviews for a smartphone might find battery life issues, camera quality, and software bugs, right. So, battery life issues has certain again words like, for example, battery drains fast, poor battery performance. Camera quality has, for example, great low light photos, great photos, sharp images. Software bugs can have, for example, app crashes, slow update, right? Or nice, almost no bug. Okay. So these are some reviews, right? And these are the topics around the smartphone. Okay. Now, in market trend analysis, suppose you are talking about market trend. So businesses need to stay ahead of the market trends. Otherwise, what will happen? The market trend is changing. If you don't understand it, then the businesses might be producing the same products which might be getting obsolete in the minds of the consumer. So the consumer is not liking it anymore, but you, because you don't understand the trend, you are producing the same item and the consumer might not buy it at all. So, and this can be highly applicable to the fashion industry, for example, which has a very short life cycle. Okay. So, topic modeling helps analyze social media, industry reports, and online discussions to understand or detect the emerging trends. So, a fashion brand might find that discussions about sustainable fashion are increasing. Okay. So, it is signaling a shift in consumer preferences. So, maybe tomorrow if a consumer, if a company is making products which are highly unsustainable in nature, customers might not purchase them because the trend is changing and customers are liking to do, are thinking about working more for the environment, saving the environment. So, they are talking about sustainable fashion now, right? Similarly, you talk about competitive intelligence. Companies can use topic modeling to analyze reviews, product descriptions, and market reports. So, by understanding or identifying the topics frequently mentioned about competitors, businesses can adjust their strategies accordingly, right? So, what the competitors are doing and how customers are responding to it, right? By understanding this, a competitive intelligence can be built for the company. Some human resource analytic examples. So, employee feedback, for example. Companies receive thousands of reviews, employee reviews, interviews, and performance surveys, right? Manually analyzing them is obviously inefficient. So, topic modeling helps to identify recurring workplace concerns. For example, a company analyzing employee feedback might find topics like work life balance issues, compensation concerns, leadership problems, career growth opportunities, and overall business impact. Now, just imagine if you there are data everywhere, right? But earlier days, because of the lack of knowledge and lack of computational power, we were not understanding how to use text data. But today you have so much of superpower, computer superpower, computer power, and you have knowledge, you have different techniques, mechanisms. So why not understand this text data, analyze this text data and get to a better condition than what you could have done without it, right? So analyzing this will help you a lot. So for employee feedback analysis, for example, human resource, it is a great way of learning how to, what people are talking about, work life balance issues, compensation issues, leadership problems. So that can be extremely good for a company to understand where they might be going wrong, okay, or where they need an improvement. Similarly, for a financial risk and market trend analysis, if you see, so financial analysts and investors need to stay ahead of risk and market shifts. For example, if you open a YouTube channel on, let's say, financial risk and or stock investment and all, you will see thousands and thousands of comments and all these things. So from these comments, at least from experts comments and all, you can make a, you can collect this data and understand what do the experts in the market feel. Are they thinking that there is going to be a bull run in the market, or are they thinking that there is going to be a lull period in the market? So, for example, in the last year or two, I realized by looking at lot of reviews from people that the FMCG sector might not do a great, have a great momentum because of the poor earning impact, right? Or let's say the monsoon does not have a good, is not doing pretty well. So it might have an impact on the agricultural earnings, and that is why it will have an impact on the FMCG industries. Okay. So understanding these things will help you to identify your investment trends and economic risks. Okay. So for example, if you see a financial firm analyzing trends, earnings, call transcripts and reports may find revenue growth trends, liquidity and debt issues, macroeconomic concerns, and investment and merger and acquisition trends, for example, and overall business impact obviously. So overall business impact for it is, for example, after reading all those trends and all, that investors and financial advisors can use these insights to make informed decisions about the stock movements, risk management and economic forecasting, right. So, these are some, so that is why understanding the text and analyzing the text becomes very, very important, right. But what are the common challenges in topic modeling? So, the first challenge is choosing the number of topics, right. How do I choose the number of topics? For example, one of the most critical challenges it says is selecting the optimal number of topics. If too few topics are chosen, distinct themes might merge into one, right. For example, if I say only sports, right, and instead of, and somebody says, let us say indoor and outdoor sports, right, which is better? Obviously, your interpretation would be better when you talk about indoor and outdoor sports differently, right. Or even you can say, even you can cluster it even, or classify it in a much more better way. For example, you might say sports in terms of economy of sports, in terms of medals, in terms of, let us say preparation, infrastructure. So, you can talk about several topics, right. So, if you make it only one, maybe you are missing out on some very important themes or important information which could be useful. But if you make it too much, for example, if I break sports into too many topics, for example, I make it 20 different topics, the sports is broken 22 different topics, then it becomes too fragmented and understanding them becomes a challenge. So, various techniques such as coherence scores and perplexity score are used to select the right number of topics. So, if you remember, for example, if I can connect you with, if you have done cluster analysis, it is something similar to the hierarchical cluster analysis, which helps you to identify the number of topics that you require, that you should, a number of clusters you should generate in a cluster analysis. Okay. So, similarly here we are using coherence score, there we were maybe using the, the coefficient values, here we are talking about coherence scores and perplexity score, right. So, what does the coherence score talk? Now, coherence score reflects how well the top words within each topic appear together in the corpus. Corpus is the document, right. So, if you have a coherence score of, there is no actual score, but if you have a coherence score of very poor, then that means the topics are highly fragmented, right. So, that is not good. So, coherence score should be at least somewhere around 0.3 or more, right. So, the maximum is 1. So, 0.3, 0.4 is ideal, or good is good, and even more is better, right. So, as I said, similarly perplexity score measures how well a probabilistic model predicts a sample of unseen data, right. So, lower perplexity values indicate better predictive performance. So, it is just the reverse, right. So, higher coherence score is good, lower perplexity score is good. Okay. So, this is the first thing. So, you choose the number of topics. Second challenge is handling noise. So, how would you handle noisy or short texts? Okay. So, short text, for example, tweets, customer reviews contains limited word occurrences, right, making it difficult to detect the coherent topics. So, advanced techniques like BERT, topic top to vector, right, are designed, topic to vector design are designed to handle such cases by leveraging the word embeddings and deep learning. So, noisy data or handling noisy text is also a challenge, right. The third is ensuring interpretability. How do you interpret, right? Sometimes topic models generate topics that are difficult to interpret. So, while algorithms like, LDA, right, so which uses say Dirichlet distribution may produce meaningful topics, other methods like also non-negative matrix factorization or NMF may require manual adjustments to enhance interpretability. So, as I said, what is this? Now, LDA is a technique which is basically used, and it is also an alternative name for continuous multivariate probability distribution, right. So, this is a method which is used to ensure better interpretability of the themes, okay, or the text data. So, these are the popular topic modeling algorithms. So, if you see, the first one is the most popular, one of the most popular. So, LDA, right, what does it say? Latent Dirichlet allocation, right, a probabilistic generative model, it is a generative model, right. Okay. The second is non-negative matrix factorization, NMF, right, a linear algebra based model, and the third is BERT topic. So, a modern deep learning based approach using transformer embeddings, right? Now, each of these algorithms has their own unique and advantages and limitations. So, it makes them suitable for different use cases. Okay. So, let us see each one of them. So, let us start with the LDA. So, LDA is basically a probabilistic generative model used for topic modeling, right, which means it discovers the hidden or latent topics in a collection of documents. So, there is a lot of what are the hidden topics in a document, right. So, you have, it uses a probabilistic generative model approach. So, if you remember, probabilistic genetic models approaches were like naive Bayes. We have also discussed when we are talking about sentiment analysis and all. Then hidden Markov models and Gaussian mixture models. Okay. So, what is the key idea of LDA? Each document is a mixture of multiple topics, and each topic is a probability distribution over words. Okay. So, let us say this example, a document about machine learning in healthcare might have, as we have seen, 70% topic on AI, right. So, words like neural network, deep learning, etc., and 30% topic B on which is medicine, like diagnosis, treatment. So, LDA automatically infers these topic distributions from the text data without prior labeling. Okay. So, it automatically generates, no, that is why it is a generative model. So, prior labeling is not there. So, what does it mean by probabilistic generative model? That is what I have tried to explain here. So, a probabilistic generative model is a type of model that assumes data is generated from an underlying probability distribution, right. It tries to describe how the observed data were probabilistically generated from some hidden structures. Okay. Structures are basically the topics. Okay. It assumes that there is a hidden process that generates the observed data. Instead of just classifying or clustering the data like in a discriminative model, it tries to explain how the data was created. More than just clustering data like a discriminative model, it says how the data was created, right. So, given some hidden variables, it generates words in documents according to some probability distribution, and largely it is used for image processing, text generation, anomaly detection. So, for example, when you are processing an image, right, it could you can it helps you to develop an image, for example, right, or generate a text, right, or detect a mistake anomaly, right. So, because it is using a probabilistic model, it is creating the data is being created. So, what is the most potential one that will be coming here, right. The model assigns probabilities to different possible ways, right, the data could have been generated. So, what are the different possible ways the data could have been generated? So, that is what this model does, right. In LDA, each document is assigned to be a mixture of topics, and each topic is a distribution over words, right. That is what we have discussed. So, finally the goal is to infer the most likely set of topics that could have generated from the observed words in the documents, right. So, by looking at the observed words in the documents, we can say what are the most potential or possible topics that could have generated, right. Now, how LDA uses this concept? Now, it assumes that each document is generated by first choosing a distribution of topics, and then picking words from those topics based on their distribution, probability distribution. So, inference is that given a collection of documents, LDA tries to reverse engineer the process and uncover the latent topics that best explains the words in each document. So, it is like trying to tell what is the most potential theme, right. So, there are 3 steps if you can see here in LDA. First is choose a distribution of topics for each document, so which is called document topic distribution. Then in the second step, choose a topic for each word in the document, which is topic word distribution. And the third is choose a word from the topic word distribution. So, these are the 3 steps. Okay. Let us take an example. Imagine you have a collection of news articles. So, you are reading newspaper, articles are there everywhere around you, and you suspect that there are about different topics like sports, politics, technology. You do not know in advance what the topics are, but you assume that each article is a mixture of topics. So, that is true also. Each topic is a probability distribution of over words, right. Now, let us see how LDA could generate an article in a probabilistic way. So, step 1, what it does? Choose a topic distribution for the document. Suppose we want to generate a new article we randomly assign proportions to different topics. Example, 60% sports, 30% politics, 10% technology. So, there is a random assigning of value, right. Then we generate words from the topics. So, now to create the article, we generate words one by one. So, first word, since the document is 60% about sports, we are most likely to choose a word from the sports topic. So, example, goal, with 10% probability, team with 8% probability. So, second we go to the second word, then we go to the second word. After the first word, we go to the second word. The second word we choose maybe politics this time with a probability of 30%, and pick a word from political topics, for example, election with a 12% probability. So, this procedure is repeated until the article is completed, right. So, the key idea here is that the document is generated by randomly mixing topics and then picking words from those topics according to their probability distribution. So, the word probability distribution is very important here. Okay. So, how LDA works in reverse? So, during the inference stage. Now, in real world topic modeling, we do not see the topics, right. We only have the words in documents. So, LDA works in reverse to uncover the hidden topics. So, it tries to estimate the most probable topic mixture for each document, and it also estimates which words belong to these topics. So, that is why LDA is called a probabilistic generative model, and assumes the documents were generated using a probabilistic process and tries to infer the hidden structure. So, by using a probabilistic modeling process, it tries to infer the hidden or the latent structure of a document, right. What are its strengths? So, interpretable topics. So, LDA produces topics as word distributions, basically lists words with probabilities. So, if one topic has high probability for words like neural, deep, algorithm, learning, we can interpret as a AI topic, right. So, this makes human understanding much easier and better, right, because we can label the topic ourselves later then. Okay. It handles polysemy and multiple topics per document. So, polysemy means words can have multiple meanings and LDA can assign them to different topics. So, the word bank can belong to finance or nature. For example, banking is finance, nature, river bank is nature, and LDA can place it in both the topics based on the content. This is the benefit. So, here the bank is not confined to only finance. Here we are using it wherever it is possible. For example, nature here and finance both. Similarly, multiple topics per document, unlike simple clustering methods like the K-means method, LDA allows the document to belong to multiple topics. So, in K-means what was happening? It was there in one cluster only, right. So, that particular clusters, according to that behavior, we were deciding what this cluster is all about. But LDA allows you to fall into two different clusters or more than that also, right. This is the benefit. So, a news article might be 60% sports and 40% politics, rather than being forced into one category, right. So, there could be politics in sports also, right, or so, but it that will not get separated in a single category. So, this is what a LDA technique helps you in. And the third benefit is it works on large corpus, right. So, LDA is scalable. You can scale it up and it can handle thousands to millions of documents, right, which was impossible for you, right, otherwise to scale it and carry, interpret millions of or thousands of documents. Since it is a probabilistic model, it distributes computations efficiently across large data sets, and this makes it useful for applications like news categorization, academic research and social media analysis. Okay. Now, these are the strengths of LDA. Now, what are the weaknesses? So, LDA has some weaknesses also. First, it requires predefined K, right, the number of topics, but that was there in, if you remember cluster analysis, if you go back to my class, you will see that this thing was there also, right. So, we require predefined K, how many clusters or number of topics. So, LDA needs the user to specify the K beforehand, right, and if you choose the wrong K, it can lead to overfitting or underfitting, too many or too few topics. Okay. So, what are the solutions? Now, hierarchical LDA. So, we were having hierarchical cluster analysis. Here we are talking about hierarchical NDA. Automatically determines the topic hierarchies. So, through this you can find out what is the best potential number of predefined k that can come. Okay. Then we can also use Bayesian non-parametrics. So, which dynamically adjusts the number of topics based on the data. Second weakness is computationally very expensive, right. As you can see, it is a probabilistic measure and it makes several different combinations, right. So, obviously the computational power has to increase tremendously. So, that becomes very expensive also. So, LDA is slow because it is working with millions of documents, right, and it requires iterative updates, right. So, for example, you are combining several making several potential combinations and checking this efficacy, right. The complexity grows as the number of topics, words or documents even increases, right. So, here what are the solutions? We can go for online LDA, which processes data in mini batches, okay, or parallelized implementations. So, we use GPUs. So, GPUs nowadays are being discussed a lot. So, GPUs are distributed computing, okay. And the final weakness of LDA is that it struggles with the short text, so like tweets and titles. So, LDA assumes that a document has enough words to infer topic distribution. In short text, it does not work. So, there are too few words, right. So, it cannot accurately detect the topics. So, what is the solution for that? So, you aggregate short text, you make, you try to compile them. So, example, grouping tweets by user or hashtags, okay, or using neural network topic models like BERT topic or topic to vector, which leverage word embeddings. So, by these methods you can cover up the weaknesses, okay. The last weakness is assumes bag of words, which says no word order considered, right. So, LDA treats document as bag of words, ignoring word order and grammar. So, for example, Apple buys Google or Google buys Apple would be treated similarly. This means LDA loses semantic relationship, right. So, one of the weaknesses. So, what is the solution? So, we use BERT topic. So, using contextual word embeddings like BERT or neural topic models which consider sentence structure, okay. With this, we have understood what is topic modeling, why topic modeling is so important, and out of the different topic modeling techniques we learnt about LDA today, right. How LDA is used, what is its utility and what are its strengths and weaknesses. With this, I will wind up today's lecture and we will meet in the next lecture. Till then, take care. Thank you very much.